Hello. So this video is going to be answering the first part. Let me post the question. And the question is explain how many moles of each species in the feed and the product are determined from the reaction given excess air. So the scenario is let's say you have a Bunsen burner and you light it up on fire and it creates a flame. So the fuel source in this example is going to be the CH4, and it's going to react with the air, and it's going to have a product of CO2 and our water. So let me write that out. Let me write the equation out, the balanced equation out of what I just said. So we have CH4 plus O2 plus nitrogen, and nitrogen is 79 to 21 part, because these two, it's the air, and this would be our fuel. And what we get is CO2 and H2O. I didn't write out the nitrogen on the other side because the nitrogen doesn't react. So I'm gonna balance out these equations, this equation I mean, which is pretty simple to do. So it's added 2. Alright, and the next step is let's look at the question. We have to determine how many moles of each species go into the feed and the product. Alright, so what we can do is we can write out our species. In this case, it's O2, nitrogen, CO2, CH4, H2O, and this is what's going in, and this is what's going out. So for oxygen, what's going in is for O2N is the 2, which is the stoichiometric, which is from right here, and there's also excess, the partial, I think it's excess, the fractional excess. So that's what's going to be going in for the oxygen. And what's going in for the nitrogen is, actually, I want to explain this part a little bit. This part right here. Give me a second. My pen isn't working. So for the reaction, what happens is when you heat it up, you want to make sure that you have enough air. And also, if you don't have too much air, then what happens is that you end up heating the excess air, and if you don't heat it enough, you only it doesn't cause combustion. So I'm gonna write out what I just wrote real quick. So too much air what happens is you don't achieve the highest temp, and you heat up the air. And not enough air. It doesn't combust, and I think when there's not enough air, you end up just heating the CH4, which can create carbon monoxide, or carbon monoxide or carbon monoxide. Doesn't combust. So what this means is there's actually an adiabatic flame temperature, and what that means is there's a adiabatic flame temperature. But I won't get into that because I don't think this is this part. It's for this part. So back to this. The oxygen that's going out is gonna be the stoichiometric times the excess the fractional excess, and for the nitrogen that's going in is going to be N2 times 79 part nitrogen and 21 part oxygen. And going out, it's really going to be the same because the nitrogen doesn't react. And for the CO2, that's going to be our product. So initially we have 0. And then going out, when we use 1 mole of methane, we get 1 mole of CO2. For the CH4, we're starting out with 1 mole of CH4, and in the end, for this reaction, we're gonna say that we use up all the CH4, so 0. For the H2O, we start out with 0 moles of H2O, and in the end, we ended up having 2 moles of H2O. This is from the equation. So I believe that answers all the parts of the question. So that's it for part 1.